Hello everyone, welcome to today's class. And our topic today will be on simultaneous equations. Okay, now simultaneous equations are equations that contain same variables. Okay, now simultaneous equations can be solved simultaneously, they can be solved at the same time. Okay, now when we have an equation like x plus y equals to 4 and we have 3x plus 2y equals to 9. The two equations have the same variables, which is x and y. These are the two variables you can find in the first equation. And in the second equation, you could see x and y. Okay? Somebody says, what if I have an equation x plus y and this equals to 4, and the second equation is 2x plus, let's say, plus p equals to 8. These two equations are not simultaneous. Why? Because we have the first equation, we have x and y. The second equation, we have x and p. These two equations, as long as they don't have the same variables, you can solve them simultaneously. Okay, take notes. Please take notes. So your equation must have same variable before you can be able to solve them together. Okay, now we have explained when we have 2x plus 3y plus 9 equals to 0. We have said each of them is known as term. 2x is a term, 3y is a term, 9 is a term, 0 is a term. They are joined together by what we call operators. Let's say this is minus, for example. This minus is an operator, plus is an operator. Each of them is known as term in an equation. Okay? Now, but to explain deeper, we have said this 2x. This x is what we call variables. It's known as variable, but the 2 that is joined to s is known as constant. Coefficient. It's known as coefficient. It's known as coefficient. So this 2 is known as the coefficient of x. So don't forget, this 2x is the same thing as 2 times x. The 2 is joined to x by multiplication. Okay? And same thing with this 3y. But this 9 that we have here is known as constant. It's known as constant. This 0 is also known as constant. Do you get it now? Now, going further into equations. Okay? Since you understand the terminologies in equations, now, don't forget there are different types of equations. There are many types of equations. Let's start from there. Types of equations. I think it's very necessary. Types of equations. I think it's very necessary for us to do this. That shows that our class will be long a little bit, but bear with me. It is very needed, very understandable. Okay. Now, number one, we have what we call linear equations. Linear equations. Linear equations are equations whereby the highest power of your variables is 1. Okay? Now, when I have x equals to 2, this is a linear equation. Why? Because the highest power of this variable is 1. Don't forget, anything raised to power 1 will remain safe. 2 raised to power 1 is still 2. 1000 raised to power 1 is still 1000. Okay? Y raised to power 1 is y. Okay? So the highest power in that variable is the exponent in that variable. The highest exponent is 1. So if I have x plus y equals to 16, for example, this is also a linear equation whereby the highest power of the variable is 1. Okay? Now, let's go to another one, another type of equation. Okay? Number 2, in linear equations, before I go, we can have as many variables as possible. You can have 3, you can have 5, you can have 6, you can have only 1. Just like you have 2 variables here. But those variables, the highest power they carry is 1. Okay? You can have 2x plus 3y equals to 8, for example. This is still a linear equation because 2 is not a power, it's not an exponent. It's what? Coefficient. It's a product. It's a product of x. It's attached to x by multiplication, not a power. Okay? 3 is a product of y. Product means multiplication. 3 is attached to y by multiplication. This 3y is same as 3 times y. Okay? Please don't mistake in that. Now, let's go to another type of equation. Number 2. Number 2, we have what we call quadratic equations. We have what we call quadratic equations. And I think in our previous video, we have dealt with solutions of quadratic equations. Okay? Now, how do you identify quadratic equations? Quadratic equations are equations whereby the variables, one of the variables carries the highest power of 2. Okay? For example, if I have x squared plus 4 equals to 6, for example, this is a quadratic equation. Why? Because the highest power of the variable has power of 2. I can have x squared plus 2x plus 8 equals to 0. In this category, one of the variable has power of 1. Another variable has power of 2. But you can't see the highest power you can have here on the variable is 2. Okay? The highest power, the bigger power you can have is 2. In quadratic equation, you can have only one variable and you can have more than one variable. For example, you can have 2x squared plus y plus 6 equals 0. This is still a quadratic equation. Though they have two variables, the two variables they have is y and x. But these variables, they carries the highest power of 2. That shows that one of the variables will carry 2. As long as one of the variables carries 2, it's still a quadratic equation. Okay, we can have another one. X squared minus y squared equals to 0. This is still a quadratic equation because in the power, you have the variable having the power of 2. As long as one of the variable has the power of 2, it's a quadratic equation. Okay? Now, number 3. And that type of equation is what we call exponential. Before I go to number 3, I have taught us on ways by which you can solve quadratic equations. And before I forget, I've said that there are 4 ways by which you can solve quadratic equation. How to solve quadratic equation? Okay, I said number 1, you can solve using factorization method. Factorization method. Okay, you can solve using completing the square method. Completing the square method. Completing the square method. Number 3, you can solve by using quadratic formula. Quadratic formula. Okay. And number 3, you can solve using what you know as graph. Okay. We have done with these 3 methods. You can check our previous classes. Just check factorization, solving quadratic equation using factorization on our page. On our videos, you see it. We have solved some examples of quadratic equations using completing the square and also using formulas. Okay? Now, you can just check those classes, you understand better. Now, these are the ways you can use to solve quadratic equations. Okay? Now, let's go to another type of equation. Number 3 is what we call exponential equations. Okay? Now, exponential equations are equations whereby the variable is an exponent. Okay? For example, if I have 3 raised to power x equals to 9. Now you see my variable, which is my x, is my exponent, is a power. Such an equations are known as exponential equations. Okay? And we'll be dealing with this in our simultaneous equations. Okay? Now, you can solve simultaneous equations in different ways. There are some methods you can use to solve simultaneous equations. There are some simultaneous equations that you can solve using what we call indices law. For example, this one, you can solve using indices law. Indices law. Especially if I have 3 raised to power x equals to 9. When you have an indices whereby you see this 9 is a perfect number, you can solve it using indices. So we have 3 raised to power x equals to 3 raised to power 2. Don't forget I've said when we have 3 raised to power 2, this 2 that is here is known as exponent. Okay? And this 3 is known as base. All right? Don't forget. Now, you see that the base are the same. The base of both sides are the same. When the base are the same, the only thing you need to do is you equate the indices. When you equate the indices, what you just need to do is you eradicate the base. And what you are left with is x equals to 2. You can solve like that. There are some of the indices whereby they are already like this. For example, if I have 2 raised to power x equals to 2 raised to power 4, you don't need to worry yourself. This can be solved directly by saying x equals to 4. Simple. Okay? There are many methods. There are different laws of indices. We have dealt with law of indices. You can check our page also. We have dealt with all this. If you don't understand what I've done, just go to law of indices in our videos. You'll understand better. Okay? Now, in some other cases, there are some of the exponential equations that it takes logarithm to solve them. For example, if you have if you have 2 raised to power x equals to 15, for example, this you can't solve this because 15 is not a perfect number. So the only way you can use to solve this is by using logarithm laws. Let me try to solve this so that you understand. Now, what you just need to do is you introduce logarithm to both sides. If I introduce logarithm, if you take logarithm of both sides, log of base 10 to both sides, in this case, we have log 2 raised to power x to base 10 equals to log 15 to base 10. The only thing that I've introduced, the only thing that has changed from this equation is this. Okay? All right? Then the next thing you need to do is you bring your x to the back. Is another law of a logarithm. So we now have x log 2 base 10 equals to log 15 base 10. Okay? Now, you divide both sides by log 2 base 10. So that means that we have x log 2 base 10 divided by log 2 base 10 equals to log 15 base 10 divided by log 2 base 10. All this one will go away and divide. Okay, we'll be left with x. Equals to, your calculator is in base 10. You can press your calculator, log 15. It will give you your answer. You press it. Log 2, your calculator is in base 10. You press your log 2, you get your answer. Okay, that's the way. Somebody say, how did I divide? Because this x is linked to this log 2 by multiplication. Don't forget when we treated change of substitution formula, I said if a number is linked to another number by multiplication, the only way you can separate them is by division. When they are linked by division, you separate them by multiplication. If they are linked by minus, by subtraction, you separate them by addition. If they are linked by addition, you separate them by subtraction. So this, if you have 2x, for example, 2x is the same thing as 2 times x. The way you can separate x from 2 is by dividing this 2x by 2, is by division. Okay, so you can check our change of substitution formula to understand that one also. Okay, now that is the way to solve that. All right, now we have done exponential equations. Okay, now let's go further. This is just we're just trying to refresh ourselves with this knowledge. Now another type of equation is what we call polynomial. Number 4, we have what we call polynomial equations. Polynomial equations are equations whereby the highest power of their variables has the power of 3, 4, 5, 6, as long as you have, if the variable has an exponent of 3 and above, Such an equation is known as polynomials. For example, if I have x raised to power 3 plus 2x squared plus 4 equals to 0. Okay? This kind of equation is known as polynomial, whereby you see the variable has a power of 3. Okay? Now you can still have an equation like this: x raised to power 4 plus 3x raised to power 2 plus 16 equals to 4, for example. This kind of equation is still a polynomial because you see the power is more than 2. When the power of a variable is more than 2, like 3, 4, 5, 6, such an equation is known as polynomials. But when the highest power of the variable is 3, it is specially known as cubic equations. Okay? For example, this one we have here is a cubic equation. When we have y raised to power 3 plus 2x plus 4 equals to 0. Because the highest power of the variable is 3, such an equation is known as cubic equation. All right? Do you get it? Let's go further. Number 5. Number 5. Another type of equation we have is what we call trigonometric equations. I think we have done some of these in our class too. If when your variables is linked to sine, tangent, cosine, cosec, and so on and so forth, such an equation is known as trigonometric equation. For example, if I have sine x plus cos x equals to 1, this equation is known as trigonometric equations. I can have cosec x plus tan x equals to 4. This an equation is known as trigonometric equations, and we are still going to deal with this now, maybe in our coming classes. All right? Now, let's go to another type of equation. That's number 5. We have a lot of them. We have a lot of equations. I'm trying to just make sure you identify equations. You understand the reason why we're doing this. Okay? Now, number 6. Number 6, we have what we call rational equations. Rational equations. Rational equations are equations that have their variables as the numerator or denominator or both. For example, if I have 1 over x plus 1 over y equals to 1 over 2, for example. This kind of equation is known as rational equations. I can have them as both. If I have x over 2y plus, let's say I have 2x over 9y equals to 4. This kind of equation is still known as rational equations. Why? Because the variable is either at the numerator or as the denominator. Somebody say, where are you seeing numerator and denominator? Now, when you have a fraction, supposing I have 2 over 3, anytime when you have a fraction, the number at the top is known as numerator. Okay? While the number at the bottom is known as denominator. Denominator. And this line is known as dividing line. Okay? Dividing line. Okay? Now, when you have variables either as the numerator or as the denominator, such equations are known as rational equations. And we are going to do some examples of simultaneous equations involving rational equations. And you'll really enjoy it. All right? That is why I'm taking my time to explain all this. Now, another type of equation, number 7, I think that should be the last. Number 7 is what we call radical equations. Okay? Radical equations are equations whereby the variables are enclosed in radicals, are enclosed in what we call roots. For example, if I have square root of x plus 2 equals to 16, for example, you see my variable in roots or cube or whatever. As long as I have root enclosed enclosed in your variable. Such an equation is known as radical equations. All right? Okay? Now let's go. Let's start our class now. Somebody say, oh, nice. If you understand what we have done now, you get what we want to do now. So our class will not be a series. It will be in series. Okay? Our class will definitely be in series so that we'll be able to touch all those equations. Now, the first thing we want to do is let's look at simultaneous linear equations. Okay? And this is what we're going to do. Now, when you have two linear equations and you want to solve them simultaneously, don't forget, for example, solve the simultaneous equations. Let's say we have A plus 2B equals to 13, and let's say we have 2A minus 3B equals to 5. Let's say we have to solve these two simultaneous equations. Now, there are three methods. There are three methods by which you can solve simultaneous equations. Number one, we have what we call elimination method. Number two, we have what we call substitution method. And number three, we have what we call graphical method. Okay? I will try and use the first two and see if we get the same answer. Now, I want to start with elimination method. Now, for you to use elimination method, what's the meaning of elimination? To eliminate. So you want to eliminate one of the variables from the two equations. Okay? Now, the first thing you need to do is you check your two equations. Do they have same variables? We have the first one, we have A plus 2B equals to 13. And the second one, we have 2A minus 3B equals to 5. Okay? These two are constant. We have said that. These two are constant. Okay? Good. Now, the first one has a variable of A and B. And the second one has a variable of A and B. As long as they both have the variable of A and B, then that shows we can solve them together. Okay? Irrespective of their position. For example, the first equation can be 2B plus A equals to 13. And the second equation can be 2A minus 3B equals to 5. You see, the position of B is first, while the position of B is second in the second equation. So, but the only thing is, we have A and B as a variable in both equations. That's the first thing you need to identify. If not, you can solve them simultaneously. Okay? Take note. Now, for elimination method, you need to arrange your variables in same pattern. So, for this one, their equations are arranged in same pattern. You see, A come first, followed by B, followed by B. So, as long as they are the same, they are in the same pattern like that, then that is good to go. If they are not, you arrange them in same pattern. Okay. For example, if we have 2A, let's say we have 2B plus A equals to 13. And the second equation is 2A minus 3B equals to 5. Okay, I can rearrange this one as A coming first, because A is coming first here, plus 2B equals to 13. I only rearrange. A plus A is coming first. Because plus is here, it can come next. Okay, so that I have AB. Okay, so that's the first thing you need to do. And the second thing you need to do is you number your equations. So I'll number the first equation as equation 1. So I have A plus 2B equals to 13 as my equation 1. And I have my second equation, 2A minus 3B equals to 5 as my equation 2. And you write it in that pattern. Okay, now the second stage is that you check which of the variables for the two equations has the same coefficients. In the first one, the coefficient of variable a is 1. I've explained that when you have x, it's same thing as 1x. 1 times x is still x. 1 multiplied by any value will remain itself. 1,000 times 1 is still 1,000. So now, invisible 1 is here. That shows the variable of a is 1 and the variable of a here is 2. They are not the same. The variable of, the coefficient, the coefficient of a here is 1. The coefficient of a here is 2. That shows they are not the same. Now, the coefficient of b here is plus 2 and the coefficient of b here is minus 3. That shows they are not the same. So, how do we make one of the variables to have the same coefficient in both equations? In the equations, the only thing you can do is either you multiply the equation by that value that will make it the same. For example, this one that is here, I can multiply this one by 2 so that we have 2a and we have 2a here. Okay? Do you understand what I'm trying to say? So if I multiply this 1 by 2, it will now be 2a and we will now have 2a here. Or I multiply this 2 by 3 and I multiply this one by 2. If I multiply this one by 3, we have plus 6. If I multiply this one by this, we will have minus 6. So if I multiply this one by 2, we have minus 6. If I multiply this one by 3, we have minus 6, plus 6. So we have 6, 6. So the coefficient is similar. So I can be able to eliminate them. Okay, now I want to make, so whatever you do to one of the variable, you must do across. So if I'm multiplying this one by 2, that 2 must multiply each term in that equation. So I want to multiply this one by 2, should I make this a as 2a? But because this one is already 2a, I just need to leave it like that. But I have to do something, multiply by 1. So that I'm not doing to this, and I'm not, as long as I'm multiplying this one by something, I must multiply this one too by something. So that, because it's simultaneous equation, that's why I'm multiplying this one by 1. Do you get it? Okay. Now, if I multiply through equation 1 by 2, I have 2. Okay, let me clean this so that will not be confusing. Okay. I've tried to clean that. 2 times a will give me 2a. Okay. 2 times plus 2b will give me plus 4b. 2 times 13 will give me 26. Okay. Now, 1 times 2a will give me 2a. 1 times minus 3b will give me minus 3b. And 1 times 5 will still give me 5. Do you understand? So, it depends on which one. If it is b I want to eliminate, I will just multiply it by values that will make the coefficient to be the same. Okay? But I want to eliminate a. Okay? Do you get it now? Now, when you see it now, we now have 2a. Because they are the same now, the only thing I can do by eliminating this is by subtraction. 2a minus 2a will be 0. I can't add. If I add now, 2a plus 2a will be 4a. So that shows I've made it complex. So for me to eliminate this, it is by subtraction. Assuming that this one has minus already, if one of the coefficients has minus, the only way you can eliminate them is by what? Is by addition. So minus 2 plus 2 will give me 0. Do you understand the principle? Good. So now, because they have the same coefficient, I will subtract. If I subtract equation 1 from equation 2, then I have 2a minus 2a will give me 0. Let me use another color. 2a minus 2a will give me 0. Plus 4b minus 3b will give me what? Will give me plus 7b. Somebody says, how do I get that? We have plus 4b minus, you see this minus here? That is the minus. We have minus 3b. Minus 3b. I've said two signs should not follow each other. That's why I put this in bracket. So I have plus 4b minus times, I've said when we have bracket, it means multiplication. Minus times minus will give us plus 3b. So plus 4b plus 3b will give us plus 7b. So 26 minus 5 will give us 21. Do you get it? Okay, now we can proceed. Now, my 7b, 0 plus 7b is still 7b, equals to 21. What do I do here? What can I do here to make b the subject of the formula? By dividing both sides. If I divide both sides by 7, divide both sides, if I divide both sides by 7, okay, don't forget 7 times b. They are joined together by multiplication. They will be separated. I've said in mathematics, when you want to separate two numbers or two figures that are joined together by multiplication, they'll be separated by division. If they're joined together by division, they'll be separated by multiplication. Joined together by division, joined together by multiplication, they'll be separated by division. If they're joined together by plus, by addition, they'll be separated by minus, by subtraction. If they're joined together by subtraction, they'll be separated by addition. If they're joined together by square root, they'll be separated by square, by exponents, square. If they're joined together by square, they'll be separated by square roots. If they're joined together by cube root, they'll be separated by cube. Okay? That is the principle of what? Of change of subject of formula. You can just check our class to understand better. I think we have dealt with change of subject of formula in one of our classes. Okay? Now, if I divide both sides by 7, I will have this. I will have 7b divided by 7 equals to 21 divided by 7. So 7 will cancel 7. I have b equals to 3. 21 divided by 7 will give me 3. Okay? Some people can decide I've eliminated b. You can go back to this process and eliminate your b. But for you to stress yourself, you cannot use what we call substitution method to get your a. By substituting, substitute b equals to 3 in equation. In equation, you can use any of the equation, either equation 1 or equation 2, any one. So you can even use this one or use this one. It's still the same. So which one do you want us to use? You want us to use equation 1? We use equation 1. So we have a plus 2b equals to 13, which is my equation 1. So wherever you see b, you put 3. So we have a plus 2 times my b is 3. Don't forget 2b is 2 times b equals to 13. So my a plus 2 times 3 is what? 6 equals to 13. If you subtract 6 from both sides, so if you subtract 6 from both sides, so you have a plus 6 minus 6 equals to 13 minus 6. Plus 6 minus 6 will be 0. So we have a equals to 13 minus 6 will give us what? 9. Okay? Will give us, what's that? That's 7 rather. Will give us 7. Will give us 7. Okay? Therefore, my a equals to 7 and my b equals to what? Equals to 3. Some people can write it like this. A comma b equals to, your a is what? 7 comma 3. It's the same thing. Or you write it like this. Do you get it? So my a equals to 7 and my b equals to 3. Let's now try substitution method. Keep your a. We want to try substitution method. Okay? You see how it is. We want to try substitution method. Substitution. Want to try substitution method. Don't forget our equation 1. We have named the equation as, this is equation 1, and we have 2a minus 3b equals to 5 as my equation 2. Now, for substitution, what you need to do is you make your one of the variable to be at one side to be equals to the rest. So now let's see. I can use equation 1. My equation 1 is very easy because I could see one of the variables standing on its own. So I have from equation 1, I have a plus 2b equals to 13. So if I bring 2b to the other side, if I subtract 2b from both sides, so I have a equals to 13. If your 2b is crossing equals to, it becomes minus. This plus will turn to minus 2b. So either use that method or you subtract 2b from both sides. That shows we have a plus 2b minus 2b equals to 13 minus 2b. I subtract 2b from both sides, just like what I've done here. Where is it? Okay, 2b plus 2b minus 2b will be 0. Okay, so we have a left at this side. A equals to 13 minus 2b. Do you understand? Okay, let's go. So now my a equals to 13 minus 2b. You can make this one equation 3. Don't forget that your equation 3 is the same thing as your equation 1. It is your equation 1 that you converted to equation 3. Both of them are the same. So now the principle is, whenever you now see a in your second equation, which is equation 2, you put the values. Don't go and put a in equation 1, because equation 1 and equation 3 are the same. Okay? So you now substitute value of a, substitute a equals to 13 minus 2b in equation 3. Okay, now sorry, in equation 2 rather, in equation 2. Okay, don't forget a equals to 13 minus 2b is your equation 3. So you substitute it in your second equation. So what is your second equation? 2a minus 3b equals to 5. This is your equation 2. So wherever you see your a, you put your values. So we have 2 times, don't forget 2a is 2 times a. What is your a? Your a is 13 minus 2b. Minus 3b now. Minus 3b equals to 5. What I've just done is I remove my a and I insert my values. I substitute my values. Okay? Now, I clean this place. Okay? Now, you open the bracket. If you open the bracket, we only have one bracket. If you open the bracket, that shows your 2 multiplied through all what we have in the bracket. That shows 2 times 13 will be what? 26. Okay? 2 times minus 2b will give us minus 4b. Okay? Minus 3b. Minus 3b equals to 5. 5. Okay? I only open the bracket 2 times 13. 2 times minus 2b. That's the only thing I've done. Okay? So, next thing you do is 26 minus 4b minus 3b will give us minus 7b equals to 5. If I collect like terms, okay, so minus 7b, okay, if 27 is coming to the other side, or what I can do is, if your 26 come to the other side, it becomes minus. Or if I say subtract 26 from both sides. I want to remove, what is attached to 7b is 26. I want to remove that plus 26. And how will I remove it? It is by what? By subtraction. So I have 26 minus 26 minus 7b equals to 5 minus 26. 26 minus 26 will be 0. So that's why I want to remove the 26 to make, that's why I make, you understand what I've done. So we have minus 7b equals to 5 minus 26 will be minus 21. How do I remove minus 7? I remove minus 7 by dividing both sides by minus 7. So if I divide both sides by minus 7. So I have minus 7b divided by minus 7 equals to minus 21 divided by minus 7. This minus, my minus will cancel my minus. Okay? Minus will cancel minus. 7 will cancel 7. Minus will cancel minus. 7 here 1, 7 here 3. So my B